All right, we are moving on to the next section of logs. So this is solving logs using log properties. So on Monday and Tuesday of class, we talked about using these log properties, and we went over a bunch in class and really focused on three main ones that we kind of used. Let me get those to show you really quick if I can find them. Here we go. So here they are right here. We talked about, these were two that we kind of already know, but maybe have seen them in a different way. So this is when we have log base b of 1 equals 0. So if we see a base with a number 1, then our answer is 0. If we see a base and the log being the same number, so log base 3 of 3, then that whole thing equals 1, okay? So log base 5 of 5 equals 1. So if we say log of 10, that actually equals 1 because this is a base of 10 here and this is 10 here. And then the three that we used were when we're multiplying, we're adding them together. When we're dividing, when we see a division sign, that means we're subtracting. And then if we have an exponent, we're allowed to move it forward as a coefficient to kind of change around our logs in order to solve. So we're going to use those today to basically bring together 2 logs or 3 logs or 4 logs, and then we're going to actually get a number for our answer. So we're going to solve for x if there's an x, or we're going to evaluate if there's no x. So when I look at the first one, you'll see that we have the base is 2, and we have a minus here, so that tells us we're going to divide. So log base 2 of 96 divided by 3. And when we divide by 96, or excuse me, when we divide 96 by 3, we get log base 2 of 32, okay? So here is where we're going to evaluate. We do not have an x, so we can evaluate. We can do it 2 different ways. We can either do common bases, or we can take the log of both sides. So the first thing I'm going to do is set it equal to x and do my loop-de-loop here and see what I get. Okay, so I get 2 raised to the x power equals 32. So if we remember, 2 does have, we can basically figure out 2 times what, or 2 raised to what power equals 32. So if I do this on this side, 2 to the, let me check, I think it's 2 to the 5th power. Yes, 2 to the 5th power. So if that's x and this is 5, then x is going to equal 5. Okay, so again, we combine them by using the properties. And then once we combine them, then we convert to exponent form. And then we look to see, can we do common bases, or can we do, well, we have to take the log of both sides. And I think for most of them today, we're just going to be able to change them to exponent form and then do common bases. Okay, all right, so let's stick with that. The second one, number 2. I have a base of 6, so now I'm going to multiply 12 and 3. So log base 6, 12 times 3. So log base 6, 12 times 3 is 36. You can probably kind of see what's going to happen here when I do the loop-de-loop. And sometimes you don't even need to change it, because you could just say, oh, well, I know that 6 raised to the 2nd power is going to be 36, so x is going to be 2 for this one. Okay, so now let's go into those 2 were kind of easy because they didn't have any variables involved. So when we get the variables involved a little bit, so now we have log of x minus log of 2 equals 7. So the first thing I notice is that I don't see any bases written. So you have to remember that these are a base of 10. I see a minus, so that means I'm going to divide. So to bring these 2 together, I'm going to get log of x over 2 equals 7. Then the next thing I'm going to do is I want to get rid of my log to be able to actually solve for a number. So this is 10 to the 7th power equals this. So 10 to the 7th power equals x divided by 2. So this just means 7 zeros. So 1 and then 1, 2, 3, 4, 5, 6, 7. Okay, equals x divided by 2. All right, so now we're getting closer, and you'll see that I have x divided by 2, and in order to get rid of that divided by 2, I'm going to multiply by 2. So that means I'm going to get 2, 1, 2, 3, whoops, I think 1, 2, 3, 4, 5, 6, 7. I had my, there we go. So that's going to mess this one up. Let me get that one situated. So I'm using 7 zeros. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, comma. 1, 2, 3, comma. There we go. There is our answer. Okay, so again, we brought them together, dividing. So once I divided, now I have one log. Now I can go ahead and convert to exponent form and then just simply solve for x. Now solving for x could be a number of things. This is just one of them where I divided out or multiplied by 2 to get my x by itself. So let's see what happens with 4. All right, so I've got a coefficient. I can bring that back and get log x to the third power. And then I have a minus, which means I'm going to divide. Okay, so I brought my logs together. Now I can convert. So 10 to the fourth power equals, so 10 to the fourth power equals x to the third over x. Okay, well, I know that I can simplify my x's here. So I'm going to go ahead and do 10 to the fourth power equals, this is 1, this is a 3. Exponent rules say that I'm allowed to subtract them. So x to the second. All right, so 10 to the fourth is 1, and then 1, 2, 3, 4. So it's 10,000. And then the last thing I want to do is I want to get x by itself. Take the square root, and square root of 10,000 is 100. Okay, so hopefully this is starting to make a little bit of sense. I think, let me make sure this is right. Okay, yeah. I'm going to make sure I had enough zeros in there. All right, so let's move to the next one. We've got a couple more. We're going to do 3 more. All right, moving to number 5. Let me pull this down a little bit. There we go. All right, so the next one, we've got a minus. So we're going to divide. We're going to bring them together first. So once I bring them together, now I'm going to, I got my log, one log by itself. Now I'm going to do 10. So my base exponent answer. 10 to the third power equals 4 over 5x. Okay, 10 to the third power is 1, 1, 2, 3 equals 4 over 5x. All right, so in this case, my variable is in the denominator, and I don't want it to be in the denominator. I need to get it over to not be in the denominator. So I'm going to multiply both sides by 5x. And now I'm going to get 5,000 x equals 4. Okay, now be careful. You might want to divide by 4 here or something like that, but you have to realize that you want to get x by itself. So in order to get x by itself, we're actually dividing by 5,000. So yes, this is going to be a very small number because it's going to be a big fraction. So when I do 4 divided by 5, 1, 2, 3, I'm going to get it 0.0008. Okay. All right, I saved the best for last. Last 2 that we're going to kind of work on. So now we've got a bunch of things going on. I see minuses, I see pluses, and I see coefficients in front of the variables. So I'm going to move this back, and I'm going to combine my logs. 1, 2, 3. So log x to the second. This is divide because it's a minus. Okay, but this one is multiply. So multiplying means I'm going to leave this on the top. Plus, so I'm not going to put it down here with the 8. I'm going to put it up here with the x squared. So I'm going to rewrite this. Let's see. I'll put it right here just so we can see it. But then I'm going to rewrite it because I like to see the 3.5x squared over 8 that way. Okay, now we've got one log. So now we're going to loop-de-loop. This is going to be a big number. So 10. So 1 and then 7 zeros. 1, 2, 3, 4, 5, 6, 7, 3, 6. Okay. All right, so we're going to work one at a time on what we're going to do. So this is 3.5 times x squared divided by 8. So let's get rid of our 8 first. We divided by 8, so we're going to do the inverse, which means we're going to multiply by 8 to get rid of it. And now we're going to get 80. And then 1, 2, 3, 4, 5, 6 equals 3.5x squared. Okay, let me move that over so you can see it. We got two more things to do. We got to get rid of the 3.5. We got to get rid of the x squared. So I'm going to divide by 3.5. So let's do this. 1, 2, 3, 4, 5, 6, 7. Okay, so I'm going to take that and I'm going to divide by 3.5. So here is the answer that I'm getting so far. So that means this is x squared because I only have x squared on this side. And I'm going to kind of rewrite it just so that I have it this way. So 2, 2, 8, 5, 7, 1, 4, 2.86. And then the last thing I want to do is take the square root of that number. So x equals, see what that is, 2, 2, 8, 5, 7, 142.86 equals, and now we got 4, 7, 8, 0 point, we'll round to the nearest hundredths. There we go. All right, last one. Last one. Now this one's a little bit different, okay, because one, we've got a 1 here, which we have not had one with just a number. They've always been logs. So I can't combine these. These are on opposite sides of the equal sign. But what we can do is we can change this one. So if you remember from our notes from day 1, anything with a base that's the same as the log will become 1. Well, if we look here, our base is base 10. Base 10. So this thing that was here that became 1 was a base 10. And the only thing that could be 1 is if, I'm going to put this back up again, if these two were the same. So this came from something that looked like that. 1 is the same as log base 10 of 10. Okay? So if I put that back in there, now what I can do is I can combine things. Now I've got logs. I've got 1, 2, 3 logs. Everything now has a log. If everything has a log and everything has the same base, I'm allowed to essentially cancel out the logs, and I now have an equation. I've got this on this side equals this, because this is a plus, is times this. So notice that I canceled out the logs and the base, and I kept the expressions or the numbers. So x minus 6 times 10. So now all I'm having to do is just solve for x. So this is kind of a backwards distributing type of thing here. So I get 4x plus 2 equals 10x minus 60. All right, so now we just got to solve. So we got to figure out which way we want to go. I think I'm going to subtract the 10x, even though it's going to give me a negative. So that becomes a negative 6x. And then because I moved my x's over to the left, I'm going to move my numbers to the right. I'm going to get a negative 62. And then the last thing I have to do is divide by a negative 6 to get my answer as, my calculator, 62 divided by 6. I know it's going to be positive. You get 10.3 repeating. So I'll just leave it as 10.33. And that would be my answer. Okay, so that is just kind of a quick overview of how to solve using those log properties and being able to kind of condense logs and then be able to solve or evaluate logs. So hope that made a little bit of sense, and we will talk more about it in class.